Motors are fun to work with when it comes to motion control. You can lift or move objects, or maybe create a robotic arm out of it. But what if we need that control to be precise? We can work with two types of motors, stepper and servo motors. How are they different? In this video, we will take a look at how we can use both motors and get an idea on how they are used. Let's vault in. Stepper motors have precise rotation without limits in turn angle. Also, it has a constant holding torque without needing to power on the motor. This is commonly used for printers, industrial machines, medical scanners, and digital cameras. On the other hand, servo motors are high-performance alternative to stepper motors. They're fast, high torque, and implements highly accurate precision. The angle of rotation for most servos are limited to 180 degrees. They are ideal for robotic arms, RC cars, or anything that needs ultra-precise motion control. Servos only need to be controlled with PWM tuning, and there is no worry when it comes to current draw to drive the motor, due to the servo controller regulating it. The stepper motor, otherwise, need a motor driver as a control circuit, and we need to use an external power supply as the stepper motor draws about 180 mA to 250 mA of current. It is not recommended to use the 5V pin from the Arduino as power supply. Also, make sure that all the circuit must be in common ground. Let's start with the stepper motor. Connect the terminal of the motor to the motor driver circuit board. Then, as you can see, I have limited resources, especially when it comes to wires. You can follow the schematic shown here. I just directly inserted the pins to Arduino ports. Again, use an external power supply for this. Next, here is the step operation of the motor. We will apply the full step drive, where two phases are always on to provide its maximum rated torque. A video from DroneBot Workshop beautifully explains this concept in detail. Link is also in the description. There are 4 steps in a full step drive, and we will send a high signal on the stated pins per step. There are other drive modes for this motor, but we will focus on full step drive as a basic understanding on how to use these. Then, let's proceed to writing our code. Oh, this? Oh, it's just my favorite IDE for programming Arduino. PlatformIO IDE. I'm having problems when it comes to build time, as well as no IntelliSense are installed in the Arduino IDE. Ever since using this, my development became easier. Faster build time, IntelliSense, debugging capabilities, and many more. I will link the installation tutorial below. Anyway, let's create a new project called Stepper Trial. First, we need to declare the ports that we use as input pins from the motor driver. Then, we will set the steps per revolution. The steps per revolution of this motor is 32. But since it has a gear ratio of 64:1, we will multiply it, getting a full revolution in 2048 steps. Next, we will declare a step delay of around 4 milliseconds. As the name implies, it is the delay time in between steps, or we can say that it states the RPM or revolution per minute of the motor. Next, we will set a boolean for the rotation of the motor. Lastly, we need to set an integer for the number of steps. We will now create a void function to handle the number of steps occurred in the process, as well as resetting it when necessary. We will pass the maximum number of steps, which is 3, since we will start count at 0. Then we will create another void function which will handle the process per step. In here, we will send a high signal to the pins in order. This is based on the diagram that was presented earlier. After that, we will create another function which will handle the steps in a revolution. We will use the for loop. On the first loop, we will do a full revolution clockwise. Then on the next loop, we will do the same but counterclockwise. In the setup function, we will just declare the ports as outputs. Then on the loop function, we will call the rev function. And that's it. In order for us to see what is happening per step, we will adjust the step delay by 500 milliseconds. Now, it is clear on how stepper motor works. But wait, there's more. There is a stepper library in Arduino, which is basically what we did in fewer lines of code. Let's do that, shall we? Since I'm using PlatformIO IDE, we need to download that library first. Then, let's delete the functions and include the stepper library in our code. Next, we need to declare a stepper instance and we'll pass the steps per revolution as well as the input pins. Notice that pins 2 and 3 are interchanged. That is due to the library because not all stepper motors are built with same pinouts. Take note of this because when done incorrectly, your stepper motor may not function properly. In a setup function, there is no need to declare the pins as outputs. We just need to set the speed in RPM. Then in the loop function, we just need to set the steps for the clockwise and counterclockwise rotation. Upload and done. The code that we did earlier on has the same function with the library that we just used now. Using libraries are nice when it comes to quick and easy development. But when we want more control to the code, such as memory management, we can create the needed functions manually. Let us now proceed with the servo motor. There are 3 wires attached to it. Red for 5 volts, brown for ground, and orange for PWM output. Great. Now let's create a project, name it Servo Trial, then include the Servo Library. Next, we will create a servo instance and name it myServo, then declare an integer which will contain the angle for the sweep function. The first function that we will do is called direction, where we will tell the angle of rotation of the motor. Remember that most servo motors have a maximum rotation of 180 degrees back and forth, so we'll stick to that values. Set a delay interval between angled rotations. Then the next function, we will call it sweep. We will use a for loop to create a motor from 0 to 180 degrees and delay it by 50 milliseconds per angle turn. To rotate counterclockwise, we will just reverse the for loop above. In the setup function, there is no need to set the PWM pin as output. It is done by the library. We will just need to call the attach function and declare our PWM pin in there. Lastly, in the for loop, We will call the direction and sweep function with delay intervals for function. Upload and done. We can now see the motor rotating at a specified angle, then it goes from 0 to 180 degrees back and forth. But the sweep function is a little bit slow. So, we can change the delay interval to less than 50 milliseconds, then re-upload and voila! Now, it is much faster than before. As I've said earlier, there are different applications for both motors, as both give accurate and precise motion. Stepper motors are ideal for lower acceleration and or high holding torque applications, such as 3D printers and etc. While servo motors are best suited for high speed, high torque applications or those that require high dynamic response. I do hope you learned a lot from this video and gain inspiration for your next robotic project. Maybe a prototype for automatic dispenser of hand soap or alcohol perhaps. Anyway, if you enjoyed watching this video, please like, share, and subscribe. Never stop learning, and I'll see you in the next video.